Hello, and welcome to Tech to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Kevin Buckner.
Thank you, William. I appreciate that. So today I've decided to do a case study on realizing the expectations of the customer. And typically we get asked all the time, can you clean this to 100%? Now that's their expectation. And we sometimes have to realize that expectation or try to manage that expectation, if you will. This opportunity arose. It's an application that we're starting to see more and more and more of remanufacturing, if you will. We'll discover here what we could deliver versus the expectations for what we could deliver and how they can sometimes differ with what we see with what is actually seen from the customer's perspective. So in this case study, we're talking about a modern engine remanufacturing plant, right? And they're looking to improve their cleaning process, right? So they're cleaning engine blocks and valve head assemblies, very, very common type items. Their process currently, the old process that they had was running 32% concentration of chemistry, which is quite high. And then they were running an ultrasonic soak for about 30 minutes. And then they were double running these parts through a pair of parallel 15-foot inline cleaners, out of one, hop over the rail and come into the other side. So after these steps, the parts, on their own words, their parts seem to be coming out only about 60 to 70% clean. And typically at that point, then they require an initial 10 minutes of manual blasting. If you're not familiar with manual blasting, we're talking about a guy, a gal standing by a big chamber, if you will, hands inside, blowing a media into a chamber onto these parts to try and clean the remaining soils that are left. This is a very expensive process. This particular plant has 12 of these, so 12 people standing in a row. They have 3 to 4 bags of media set up to be used for the next couple of blocks that go through. Blasting media is very expensive. Now, also, there's a test that they run. So this test that they run is called a millipore test. So after it comes out of the blasting, they'll actually flush out the water chambers, the cooling chambers inside the block itself, if you will, and they'll capture all of the blast media that went inside. They measure that. If it doesn't pass, they have to go back into the wash and process the whole block again to try and clean it all out. It's very difficult to remove blasting media. And then one of the considerations that we like to consider is their chemistry is only lasting for 4 days. So they may run Monday through Thursday, but Friday is a down day for them. They have to clean out the tanks, and some of these tanks are 200, 250 gallon tanks. They got to clean out the tank, dispose of the material set, get all the sludge material sets, because don't forget you are removing stuff, get all the sludge material sets out, and then refill those tanks. And that's a good 4 to 5 hour process. So the challenge here, so here's the interesting part, I think, of this opportunity. When asked what his expectation of clean was after a chemistry wash, he told us 100%. He wants 100% clean, but he only wants half the chemistry to be used. So we've got to cut from 32 down to 15, 16%. Well, now I believe, honestly, take the salesman hat off, I believe, honestly, that we have the greatest product for remanufacturing cleaning on the marketplace. There is no doubt about that. But 100% clean, that's tough realization. That really is. So let's take a look at what we're actually trying to clean. So this is a head. This is what they typically look like, right? So this is burned on carbonaceous oil soils that are inside these parts. And this is expected to be 100% clean after just running through one type of wash. So it's at this point I said, okay, let's truly talk about the expectations and what I can and what I cannot deliver. So what if I can lower your concentration to half of your current percentage? We started at 32, so we've got at least a chance to go down to 15 or 16. What if I could lower your run times in the inline to just one pass? Think of the time savings, 15 foot long, 1 minute per, that's 15 minutes plus loading and unloading. What if I could drop or even eliminate your 30-minute ultrasonic soak time? Now, again, that's not just 30 minutes. We're talking about 10 minutes to load, 10 minutes to unload. You're talking about 50 minutes. It could be 50, 55 minutes, could be an hour, especially if you're waiting for blocks to come through. And finally, what if we do lower that manual blasting? What if we lower that time of manual blasting? Your cost savings go through the roof. But even with all these hopefuls, if you will, I can't offer 100% clean after just a wash. I've been doing this a long time, and it just does not happen. So what I asked was, can I get one inline cleaner? Can I get one rotational cabinet washer? And can I get 24 hours to get results? And his response was, yes, or you're going to get removed. So review, we've offered to cut his chemistry costs greater than 50%. An additional 15 minutes of wash time saved per block, which is actually more than that, with only one pass through the inline washer. An additional 30 minutes saved per 12 blocks by eliminating that ultrasonic soak, which is actually 50 minutes. And last but certainly not least, let's eliminate 7 to 8 minutes of blasting per part. These are big things for these big companies. There's no doubt about it. He said, you can do that, you got a deal. So the solution, this is what we put forward at this point. So we ran some calculations and looked at the expectation of what we were doing. Now, whether it was unrealistic or not attainable, we still have to try and attain it. So we chose the 6355, and that's definitely the best choice because it's a spray and air type cleaner. So it'll work well in the inline, it'll work well in rotational cleaners. And we were put into the same piece of equipment, so we had to manage that on the same day as well. We decided to run 10 minutes in the rotational washer, which is a good, I think is a good time, a good starting point, if you will. And then, of course, 1 foot per minute in the inline. That was their current speed, so we decided not to change that. Again, we're trying to keep that time frame in. Then we ran it at 15% concentration. Typically, we run these products right around 145 degrees. Got to get them up to temperature before you run them. So here's the conclusion. This is the fantastic part. Are we 100% clean? No, we're not. We're not 100% clean. But the expectation which was laid down at the very beginning was clearly met. We dropped his concentration chemistry consumption by 17% per bath load. Now, if we remember, they're cleaning out every week. So they're saving that amount of money. Just that 17%, they're saving it right off the top. We found that we could only run one pass through the inline cleaner. That's all we needed to attain what we were trying to achieve. We did decide that a 10-minute soak time in an ultrasonic tank was still very advisable to help loosen some of the soils. And I understand that's not 10 minutes now, that's 30 minutes. But we've cut 20 minutes off of that timing. So if you multiply that out times a 16-hour, time frame of 2 shifts, which they actually run, that's a lot of time that we've saved them. We took their manual blasting from 10 minutes down to 2 minutes for each block. This is huge. It's huge not only for their time savings, for their labor savings, and for their manual blasting media. Not only that, QC really likes the idea of us not being inside and having all that dust and blasting media going into the water jackets of the engines. It makes a huge difference to QC. One of the added benefits with how our chemistries are put together is their bath life. It went from 4 days to over 10 days before a change out was needed. Now, they actually changed it out because they had it in there for 10 days. It wasn't because we weren't cleaning. They got nervous. And the amount of sludge that's coming off, because we're really working hard, they got nervous and just said, you know what, 10 days, that's fantastic. We're going to go with it. And they cleaned it out. So in conclusion, let's take a look. This is a reminder of where we began. This is that head. This is the head that we were talking about earlier. And you can see the carbonaceous burned on soils. This is the product that came out after our wash. Now, are we 100% clean? No, but we've laid down the expectation not to be 100% clean. These are valve guides and all types of stuff. And if you look closely, you can see a little bit of residue still left inside, a little bit down here, a little bit down here. But this now takes 2 minutes to clean. Unbelievable results with these type of cleaners. So I get a couple of frequently asked questions on this topic. And the first one is, can these products be used on all metal types? The answer is yes, with a small caveat. Aluminum, steel, and iron is not a problem at all. The only time we've seen a slight issue is a darkening of a magnesium type blend for a valve cover. So yes, they are multi-metal safe material sets. How do you determine a bath load? Well, we're talking about an NVR test, which we can happily do. It's a very inexpensive test. It simply takes a known volume of solution, puts it under a heat lamp, evaporates off everything that can be evaporated, leaving non-volatile residue. Then a simple calculation is made between those two to tell you what level percentage your bath is loaded. When do you typically add chemistry to a bath? With these chemistries, I definitely recommend a titration type product. Take a sample, you're going to use some drops, put some drops into it. Eventually, it's going to change color based on the concentration of the liquid itself. And at that point, you know whether you have a strong concentration of chemistry or water, and you need to add either chemistry or water to your bath. And what if there's an effluent issue at a plant? This one comes up a little bit as well. I can't drop chelators into my wastewater stream. Well, don't forget, chelators are the parts that's removing some of the metals that come off of these parts. And it's more the precipitation of a metal into the wastewater stream that causes more of the problem. Well, I'm very lucky. This plant happens to have their own wastewater treatment plant where they're doing a lot of evaporation. So they get a sludge, they put that into a sludge press, and then they handle that as an actual dry waste product going out the building. But but the great thing about Kaizen is we have other products that are available. We have a product right now which has different chelators involved in it, which is coming out with fantastic results. So we're very excited about that. So with that, I'm going to conclude. I'm going to turn it back over to William, and have a great day.
Thank you, Kevin. Thank you guys for tuning into this Tech session. If you would like to discuss this topic further or have any questions not answered during the session, please contact your local Kaizen regional manager or send an email to tech@kaizen.com, and we will have someone follow up with you as soon as possible. To download the case study this session was based on, click the link in the description. Do you want to have exclusive access to future content sent directly to your inbox, or do you know someone who'd benefit from these sessions? If the answer is yes, just go to tech2tech.kaizen.com and fill out the subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.